Okay, it says that solve lim integral from 0 up to infinite sine x over n over 1 plus x squared dx as n tends to infinity. So such types of limit is solved by using the Lebesgue-Dominant convergence theorem. So first, let us try to discuss some concepts of the Lebesgue-Dominant convergence theorem. Look, it says that let x m and mu b, let it be a measurable space. A measure space and the sequence f sub n run from 1 up to infinity b a sequence of, look, it be a sequence of non-negative measurable function. Look, this sequence be a sequence of non-negative measurable function, and also it converges pointwise almost everywhere on x. Look, then we have the limit of fn as n tends to infinity. We have the limit of fn as n tends to infinity equal to f. With this we have an integrable function g which dominates f with absolute value of fn less than or equal to g. Then actually here for each n and elements of natural number, then we have the following two prepositions. The first one is f is integrable, and the second one is the limit of integral over x fn d mu as n tends to infinity equal to the limit of f d mu of which is equal to the integral of f d mu over x, besides to that of the integral of fn d mu exists. This thing should be satisfied. So this is the so-called known as the Lebesgue-Dominated convergence theorem, or simply the dominated convergence theorem, or simply DCT. So now let's try to see how we can solve this question by using the DCT, which is the limit of integral from 0 up to infinity sine x over n over 1 plus x square dx as n tends to infinity. Look, first we have tried to put fn is equal to sine x over n over 1 plus x square. Now let's do the limit of fn as n tends to infinity, means the limit of sine x over n times 1 over 1 plus x square as n tends to infinity. Look, now this is equal to, now here we have, if we have put a very large number over there, it should be 0. Then 0 times 1 over 1 plus x square is 0. Look, the limit of fn as n tends to infinity is 0. Now let's try to find an integrable function which dominates fn. Look, so to do that we have absolute value of fn, which is equal to absolute value of sine x over n times 1 over 1 plus x square. You know, this is always less than or equal to 1 over 1 plus x square. It's clear. It's clear. Thus the integrable function which dominates fn is this one. Thus g of x is equal to 1 over 1 plus x square. Now let us check whether g of x is integrable or not, which means integral from 0 up to infinite g of x, which is equal to integral from 0 up to infinite 1 over 1 plus x square dx, which is equal to arctan, or simply tan inverse of x evaluated from 0 up to infinite. You know, this is equal to pi over 2. Simply you have to evaluate, you know, this one over there. Now we have here this one. Look, the integral of g of x from 0 up to infinity is pi over 2, which is finite, which is less than infinite. Thus this integrable. Also g of x dominates fn. Thus now let us apply the Lebesgue dominated convergence theorem, also called known as DCT, dominated convergence theorem. You may add here L. It's possible whether we may add L here or not. Actually, now let us apply the DCT. You know, we have discussed the concept of DCT over there. Look, all those criteria should be satisfied. Then the limit of the integral of fn d mu over x as n tends to infinity is always equal to integral of f d mu over x. You know, now simply here we'll try to apply what, you know, this concept over there. So now let's apply this concept here. So now the limit as n tends to infinite from there up to infinite sine x over n over 1 plus x squared dx. You know, this is equal to integral from 0 up to infinity. You know, here the limit of this function is, you know, 0, which is simply here we have, because here f dx is 0, and now this is equal to 0. Here we can solve what, you know, such calculus problem using the concept of real analysis, especially by applying the Lebesgue dominated convergence theorems. Already first we'll try to mention the theorems, and then we'll try to solve such questions by using the theorems. You know, so the one of the application of the DCT, the dominated convergence theorem, is to solve what, you know, such problems. For more additional mathematical videos, please subscribe my channel. Thank you for watching.